Small cells are low-powered radio access nodes that operate in licensed and unlicensed spectrum that have a range of 10 meters to 1 or 2 kilometers. They are small compared to a mobile macrocell, which may have a range of a few tens of kilometers. With mobile operators struggling to support the growth in mobile data traffic, many are using mobile data offloading as a more efficient use of radio spectrum. Small cells are a vital element of 3G data offloading, and many mobile network operators see small cells as vital to managing LTE advanced spectrum more efficiently compared to using just macro cells. ArcChart estimates that by 2017 a total of 5 million small cells will ship annually. Types of small cells may encompass femtocells, picocells, and microcells. Small cell networks can also be realized by means of distributed radio technology using centralized baseband units and remote radio heads. Beamforming technology can further enhance or focus small cell coverage. These approaches to small cells all feature central management by mobile network operators. Small cells provide a small radio footprint, which can range from 10 meters within urban and in-building locations to 2 kilometers for a rural location. Picocells and microcells can also have a range of a few hundred meters to a few kilometers, but they differ from femtocells in that they do not always have self-organizing and self-management capabilities. Small cells are available for a wide range of air interfaces including GSM, CDMA 2000, TD-SCDMA, WCDMA, LTE and WiMAX. In 3GPP terminology, a home node B is a 3G femtocell. A home E node B is an LTE femtocell. Wi-Fi is a small cell but does not operate in licensed spectrum, therefore cannot be managed as effectively as small cells utilizing licensed spectrum. The detail and best practice associated with the deployment of small cells varies according to use case and radio technology employed. Purpose: small cells can be used to provide in-building and outdoor wireless service. Mobile operators use them to extend their service coverage and/or increase network capacity. With small cells, mobile operators can offload traffic as much as 80% during peak times. ABI research estimates that by 2015, 48% of mobile data traffic will be offloaded from the macro network. ABI research also argues that small cells also help service providers discover new revenue opportunities through their location and presence information. If a registered user enters a femtozone, the network is notified of their location. The service provider, with the user's permission, could share this location information to update users' social media status, for instance. Opening up small cell APIs to the wider mobile ecosystem could enable a long-tail effect. Rural coverage is also a key market that has developed as mobile operators have started to install public access metro cells in remote and rural areas that either have only 2G coverage or no coverage at all. The cost advantages of small cells compared with macro cells make it economically feasible to provide coverage of much smaller communities, from a few tens to a few hundreds. The Small Cell Forum have published a white paper outlining the technology and business case aspects. Mobile operators in both developing and developed world countries are either trialing or installing such systems. The pioneer in providing rural coverage using small cells was SoftBank Mobile, the Japanese mobile operator, who have installed more than 3,000 public access small cells on post offices throughout rural Japan. To overcome the backhaul challenge in remote locations, they have used VSAT satellite backhaul to link sites to their core network. The Informa Telecoms and Media Consultancy also have a paper covering this use of small cells. Umbrella term: the most common form of small cells are femtocells. Femtocells were initially designed for residential and small business use, with a short range and a limited number of channels. Femtocells with increased range and capacity spawned a proliferation of terms: metro cells, metro femtocells, public access femtocells, enterprise femtocells, super femtos, class 3 femto, greater femtos and microcells. The term small cells is frequently used by analysts and the industry as an umbrella to describe the different implementations of femtocells, and to clear up any confusion that femtocells are limited to residential uses. Small cells are sometimes, incorrectly, also used to describe distributed antenna systems which are not low-powered access nodes. Future mobile networks. Small cells are an integral part of future LTE networks. In 3G networks, small cells are viewed as an offload technique. In 4G networks, the principle of heterogeneous network is introduced where the mobile network is constructed with layers of small and large cells. In LTE, all cells will be self-organizing, drawing upon the principles laid down in current Home Node B, the 3GPP term for residential femtocells. Future innovations in radio access design introduce the idea of an almost flat architecture where the difference between a small cell and a macro cell depends on how many cubes are stacked together. With software-defined radio, a base station could be 2G, 3G or 4G at the flick of a switch, and the antenna range can easily be tuned. Deployment 9.6 million residential femtocells have been deployed, representing 56% of all base stations globally, as of February 2013. In total, almost 11 million small cells encompassing public, enterprise and residential have been deployed by 47 operators worldwide. Small cell backhaul. Backhaul is needed to connect the small cells to the core network, internet and other services. Mobile operators consider this more challenging than macro cell backhaul because a. Small cells are typically in hard-to-reach, near street-level locations rather than in more open, above-rooftop locations and b. Carrier-grade connectivity must be provided at much lower cost per bit. In one survey, 55% operators listed backhaul as one of their biggest challenge for small cell rollout. Many different wireless and wired technologies have been proposed as solutions, and it is agreed that a Euro Toolbox Euro unregistered trademark of these will be needed to address a range of deployment scenarios. An industry consensus view of how the different solution characteristics match with requirements is published by the Small Cell Forum. The backhaul solution is influenced by a number of factors, including the operator Euro unregistered trademark's original motivation to deploy small cells, which could be for targeted capacity, indoor or outdoor coverage. In August 2013 the U.S. Federal Communications Commission announced a change in its rules governing the 60 GHz band, making it one of the key technologies for LTE backhaul. The regulator states in its press announcement that this move will facilitate the use of this unlicensed spectrum as a backhaul alternative in densely populated areas where 4G and other wireless services are experiencing an ever-increasing need for additional spectrum. References. External links: Small Cell Forum, Small Cell Forum Release Program, Small Cell Hub News, Think Small Cell, Introduction of Small Cells, YouTube video interview between RCA Wireless News and Senza Fili Consulting President Monica Paolini.